Good afternoon. Thank you for attending this class rather than lunch. I appreciate that. My name's Crispin. I'm a program manager in Windows Security, and this talk is what every developer should know about building trustworthy apps. And to set expectations, I'm not here to try and turn you into security nerds. I understand that you want to build apps to make money, and so this talk is more of a cookbook of don't do these 8 common mistakes so that your app isn't the one that causes somebody a security problem. First, I want to introduce the notion of confidence. User confidence it's not a property of software directly, it's an experience that the user has that nothing bad seems to ever happen to them, no matter how many apps they try and buy and uninstall and try something else, so that they are confident to go ahead and buy your app. Yay! So that's an experience the user has, but the software induces that experience by being reliable. Part of that confidence comes from 3 legs. One is the store onboarding process. What they're looking for is apps that just don't conform to platform policies or outright malware, so that users can be confident that your app is not out to get them. So, okay, good. Then there's the store platform, the Windows platform that provides app isolation, so that this app can't mess with that app or with the other app, so that the apps don't meddle with each other. And the third leg is app developers using secure development practices. So broadly speaking, you could say that Windows has your back. Your job is to defend your front. Apps can be attacked from various places, mostly when the app interacts with the world. That if you go and talk to the network, you could get bad things happen on your network. If you talk to neighboring apps, then they can do interesting things to you. Apps that host powerful resources, such as passwords to the user's social networking sites or their bank, become interesting targets that attackers want. And so that's one reason why an attacker might want to go after your app. Apps can leak valuable secrets onto the network if they're sloppy about how they do network traffic. And apps that are hosting valuable data on a PC that can be physically stolen are at risk. So the talk, we're going to go through these 8 pitfalls of things not to do. They break down into these 2 categories. There's excess capabilities. The Windows Store platform has 14 or so capabilities that you can declare that light up additional functionality for your app. You want to declare the minimum possible, because the more you declare, the more your app poses a threat to the user. The other 4 pathologies are insecure sharing, that whenever your app shares data with the cloud, your server, some other app, there are secure and less secure ways to go about it. So first of all, your app handles files, and you might think, oh, well, I guess I better go declare some of those file capabilities, right? Not really. You only need the file capabilities if you're going to be doing programmatic access to files. The pitfall is just declaring them anyway. You don't really need them. What you should use is the built-in file picker that comes with the platform. You only need the capabilities for programmatic access. So say you were building a music playing app. It would be tedious to force the user to go back to the picker every time they want to play a new song. They want to play playlists. So you declare the music capability to get access to all the music files. But for the most part, if you're building a notepad-like app, you just call the file picker, and it opens up the picker. It's a very nice picker. These are my cats. It gives you a text-oriented view if what it is a bunch of documents. It gives you a picture-oriented view if it's a bunch of pictures. It knows what it's doing. And it lets the user pick any file they want and hand it to your app. So unless you're building a player of some kind, just use the picker, please. So what are these capabilities? Here they are categorized by function. The file or library capabilities, pictures, music, video, and documents, As I said, you only need these for programmatic access to files. Otherwise, use the picker. The device capabilities are pretty self-explanatory. Webcam, microphone, location, you declare them if you need that device functionality. The network capabilities, this is easy. For most of you, just use Internet Client. That lets your app access the web the way a web browser would. So that's harmless, it's easy, it's on by default in the IDE. So just do that unless you're doing something unusual. For instance, client-server is there if you need to do peer-to-peer things. Fundamentally, it lets your app call listen. And you might need that if your app was a chat app or a file-sharing app or something where two PCs are going to talk directly to each other without going through a server. And the private network capability, that exists so that your app can access the local area network in the home or in the enterprise. So please only use that if you actually need local area access. The last class, enterprise authentication and shared user certificates, these are primarily for enterprise line of business apps. If you're building an enterprise line of business app, then yeah, you might need these. If you're building a consumer app, you don't need them. The store also classifies these three, documents, enterprise auth, and shared user certificates, as special use capabilities. They're only available to company accounts, not to personal accounts as a developer. And if you declare them, it subjects the app to additional inspection when it's being onboarded. You end up in the slow lane as they approve your app. So really don't declare them unless you're sure you need them. Read the docs on when it's appropriate to need them. Pitfall 2 is using a capability to store your app state. Every app gets its own app state folder that we just give it to you. You put your app there. It does nice things like it gets roamed through the cloud to the user's other PCs. So, for instance, if I have my high scores on this PC and then I go use my tablet, oh, look, there's my high scores and my levels and all the state that you want. It gets pushed around for you. But if you go and declare a capability and try and shove your state into the user's data area, none of that happens. So it's not good for you, and it's not good for the user, because then if they go to uninstall an app and some of the state stays behind, hey, I don't get my disk space back. So please keep your app state in your app folder, and it keeps you from having to declare one of the scary capabilities. Pitfall 3, shipping with debugging capabilities on. So there you are developing your app in your test environment, and naturally your test server is on the same network as your workstation, and you quickly discover that you need the private network capability to be able to connect to your test server. And then you go and put your test server in production, and you ship your app, and oops, you left the private network capability on. App still works, but that is an excess capability. It is not necessary for the production environment. It's only necessary for your test environment. And this is just a common oops that we see a lot. So just please check for that and turn it off before you ship it to us. Maybe your app really does need private network. We can't tell. It's your job to turn it off if you don't need it. Pitfall 4 is declaring any of the enterprise capabilities in a consumer app. They're just not needed. And in particular, the enterprise authentication capability doesn't even work unless it's a domain joined PC. It just doesn't do anything. So don't unless you need them. So to summarize the capability pitfalls, capabilities expand your app's access to certain key resources that users are sensitive to, and therefore the users are going, why is this app needing access to that? So try to minimize them, and that enhances the user's confidence that your app is okay for them. So the more capabilities you declare, the more customers are wary of buying your app, and the more attackers are interested in attacking your app. Use only the minimum necessary. This is in the literature, you'll find this called the principle of least privilege. Now moving on to the insecure sharing capabilities. Not using HTTPS. You see this a lot. You see this a lot in every app market, because unlike browsers, there's no URL bar. So the users can't tell whether this connection is SSL or TLS or whatever or not. Users tend to just assume everything's good. Yay. And so some developers just don't bother to use SSL because no one complained. And the pitfall is, so your user takes this to a hotspot, public hotspot, and bad guys are there. Bad guys now can see your traffic. Maybe you sent a password in the clear. The bad guys can snarf that and poach the user's account. Traffic coming back. The bad guys can play a man-in-the-middle attack and inject JavaScript into what you thought was just a benign web page, and now it's full of bad guy malware code. So please try to use SSL whenever you can, especially when connecting to your web service for your app. But perhaps you haven't bought a server certificate. Turns out the platform has this really cute feature where it enables you to securely use self-signed certificates. You probably have heard that self-signed certificates are bad. They're bad for browsers because the browser sees a self-signed certificate and doesn't know whether it's actually that certificate or there's been a man-in-the-middle attack. But if you use this feature, you can embed the certificate in your app. And now the app actually does recognize your self-signed certificate. You get an absolutely secure connection between your app and your server. You don't have to pay for the certificate. Oh, and even revocation is easy. All you have to do is push a new certificate onto your server and publish an update to your app. There, you've embedded the new cert. Pitfall number 6. Trusting untrusted sources. The scenario here is, suppose the Fabricam company created an instant messaging app. It's for all that texting thing the kids do these days. And you offer a protocol, which is an invitation to other apps to use your app to do a thing. In this case, it's send text messages. Yay, so I can fab message my pals about this cool stuff that I just found over here by using the protocol. The pitfall is acting on the protocol without user validation. So if what that does is immediately send a message, you're inviting other apps to spam all of the user's friends via this protocol. And then they go, hey, why are you sending me these annoying fab messages about, fake Rolex watches and herbal remedies that will do something? What? So the guidance here is get the user in the loop so that the protocol is invoked, the messaging app comes up and says, hey, user, do you want to send this? But of course, it's well known that mother may I prompts of, should I do this thing you just told me to do, really annoy the users. But there's a way around that. Come on. Instead of saying, mother may I, do you really want to do this thing, ask for a comment. This is the mail share interface from Win8. And it's saying, oh, you're about to send this content here. Why don't you add a comment to your friend about what you have to say about this thing you're about to share? This is a consent prompt because there's a cancel button. But the user doesn't know that. The user thinks they're adding a comment. So it is not perceived as a stupid mother may I message. But it still has the security effect that the action is validated by the user. So other apps can't manipulate your app without user consent. Another form of trusting untrusted sources, you might declare a file extension for .mp3 and Windows Media files. This is your media playing app. You declare these things so that when the user's in the file picker somewhere and they double-click on a sound file, it invokes your app. That's cool. The pitfall is that this invites any app to cram any file into your app by just calling it an MP3 file. It says .mp3 on the end, but there's no rule says that it has to be a valid file like that. And so attackers can create deliberately malformed files that break the parsing in your app take over your app, and now they start doing whatever your app is capable of doing on the attacker's behalf. And the guidance here is be careful when implementing file activations. Use system libraries if possible, because they're parsing these media files is complicated. Parsing any complicated. And like the Windows Media Foundation layer does a great job of parsing that stuff. So you don't have to know how to parse these things to create a music player. You can just do the user interface and let Windows parse the music content. And if you really have to parse your own complex file formats because they're not a standard format, think about doing it in .NET code, because that tends to be much more robust against buffer overflows and malformed data formats than C code. Wrong button. So summing up the trusting untrusted inputs, an untrusted source is any input to your app that didn't come from your server or your user. Neighboring apps, intrusive web weirdos, file invocations because you've declared yourself to be a handler for a file type, protocol handlers because you invited other apps to talk to you that way, share contracts of, hey, why don't you share this? Sharing is cool, but look out for what's coming in. You don't know what it is. App interactions allow other apps to present anything to your app. So you need to basically handle the weirdness of, oh, I don't know what that is, so I'll fail out with some kind of message. If your app enables app interaction features, you should not trust it, validate it with the user, have some kind of user interaction before you commit the transaction, and parse carefully, preferably with system libraries or at least with .NET code instead of C code. Pitfall number 7, enforcing service policies on the client. Now, I often see this, that suppose, for instance, that the Contoso Cloud Service Company has created a cloud storage service and an app so that you can put your files on their cloud. And this is all free, so they're trying to save money, and so they implemented a 20 megabyte per day transfer bandwidth limit. But they put the enforcement of that limit in the app. Who sees a problem with this? The user can hack the app to remove the limit and share torrents all day long. And that starts costing Contoso money. The threat here is that the user is trying to cheat the policy. Then they remove the 20 megabyte limit. The guidance is always authenticate the user and enforce your policies on the server against the user. So instead of saying that this client gets 20 megabytes a day, what you should say is, oh, hi, Bob. Bob gets 20 megabytes a day. Thanks, Bob. And I don't care what software Bob is actually running out there, because you can't actually know that. Always enforce your security policies in the cloud on your server instead of trusting the client software. Finally, the unencrypted passwords pitfall. Suppose the PC gets stolen. You lose more than your hardware. If you leave passwords on the drive unencrypted, then the guy that stole the PC can unmount the drive and go, oh, look, passwords, cool. Now I can rip off accounts and spam the user's friends, or, oh dear, bank accounts. There we go. So the threat is that the passwords can be read by the thief. The guidance here is always encrypt your passwords, and we provide a feature for that, Credential Vault. Credential Vault is very handy if you were here for the previous talk. It's a very simple thing. You store user identity like bob@socialsomething.com and a password, and it associates those two. And then when you want the password back to re-log in the user to that service, you just ask CredVault, hey, what was Bob's password? Okay. It provides credential isolation, that when your app stores a password, Credential Vault will only give that password back to your app, so it doesn't leak to neighboring apps. It's encrypted with DPAPI, so if the attacker tries to dismount the drive, all they see is crypto bits. The bits are only decrypted when the user logs in with their login password. So as long as the machine was locked when it was stolen, the passwords are safe. This same scenario happens, only worse, if what you have is a business app that's storing customer data. So Bob's a traveling salesman, and he has the entire customer Rolodex in his app. The PC gets stolen, and now suddenly he's up against SB 1386 or whatever it is that says you have to disclose when more than a few thousand of your customers get disclosed to a possible attacker. Oh, that's unpleasant for your business. So instead of leaving customer data unencrypted on the drive, your app should use DPAPI, which is available in the crypto namespace, to encrypt all your customer data. An alternative to DPAPI would be drive encryption. WinRT devices always have drive encryption on by default if you use a connected account. And enterprise SKUs, you can mandate that your users turn on BitLocker, or you can use a third-party drive encryption feature to encrypt the entire drive. But then you have to, in either of those scenarios, you have to be an IT department that says, okay, all my users are going to use drive encryption. If you want to ensure that your app's data is encrypted regardless of whether the PC in question used drive encryption, that's what DPAPI is for. But I just want to note, because there's been some confusion on this point, that encryption is not security. Encryption is encryption. It only protects the data against a stolen PC. It does not protect the data against malware on the PC. If the PC gets infected, then the malware gets to run as the user, gets to read everything the user can read, gets to decrypt all the crypted stuff. So the protection against malware fundamentally in Windows 8 is the app isolation. If the user mostly is purchasing apps instead of desktop stuff, then they're far less likely to be infected. So the sharing summary, encrypt everything that you can. When you send over the wireless, please use HTTPS, SSL, TLS, whatever you want to call it, and leverage the self-signed certificate feature if you don't feel like purchasing a certificate. So I don't have a certificate is not a good reason to not do it. Don't trust untrusted sources, which is file activations, protocol activations, sharing contracts. They're all invitations for any app on the box to send anything they want to your app in the guise of these invitations that you set out. So you should validate before you commit transactions, get the user in the loop to make sure the user intended to do this. It's not just some app said. And parse carefully. Use system libraries is the best way. If you have to parse your own complex content, use .NET because it's safer. Don't trust your own app clients. If you have security policy on your servers that you care about, enforce it on the server against the authenticated user instead of trying to enforce it on the app. There was a question earlier today from someone who wanted their game to protect levels and so forth, and they wanted to figure out how to prevent the app from being modified. And fundamentally, you can't. You can make it more difficult. The platform makes it more difficult. Windows does stuff to try and validate the signatures on your app and will complain if they've modified it, but this can be hacked. It's the user's PC. There's fundamentally no controlling the user. They own the PC. But if you enforce it on the server, then you can enforce it. You can even if you need to support disconnected mode, you can just wait until the user reconnects and go, hey, we didn't sell you that level 5. Come on, and impose whatever discipline you want against the hacker user's account. So security policy needs to be enforced on the server. And finally, encrypt data at risk to protect against stolen PCs. Passwords are always at risk, so use Credential Vault. It's really simple and easy. Customer data, other sensitive data, you own your data. You know what would be sensitive if it got stolen. DPAPI and full disk encryption are your answers there to protect your sensitive data against stolen PCs. So in conclusion, the Windows runtime provides this nice, rich foundation for rich, fabulous apps, and that's what you guys are here for. App developers complete the security loop of delivering apps that users can have confidence in. Customers prefer apps that make them feel confident. So avoid these 8 pitfalls to make sure your users are confident. I'll leave that up for a minute while take a picture of it and take questions. Sir.
There used to be a security tool that you would run against your sites that would point out those weaknesses that you accidentally coded in. Do you have one that you recommend that's a Microsoft?
There are many websites. The question, I suppose that was on the mic, so thank you. There are many website security scanning tools. That would be not my department, so I don't remember if Microsoft has such a product, but there's lots of them. Sorry, light's in my face.
So we put the password in credential vault, and then say the device is stolen. What happens? Does it stay forever in there? Or what happens to the password? Is there a way to remotely destroy it? Or?
No, there's no destruction. It's sitting there on the disk encrypted. To be able to decrypt it, the attacker has to obtain the user's login password. So, like the login to this PC password, all the credential vault and DPAPI stuff is encrypted using the login password. So they can sit there all day long guessing passwords, or they can just burn the drive.
Okay. And if they were able to log in, if they create their own account and log in, they still can't access?
Well, if they don't have a login, then they can't log in and they can't create their own account.
Okay. Like say some of the devices that we use at our company has a guest login. Mm-hmm. So if they were able to use the guest login and log in, can they? The
guest account is not permitted to create accounts.
Okay.
And actually, even if they logged in as administrator, it's still not good enough because the user's Cred Vault data is encrypted with the user's password. Okay. Where they become at risk is if that user subsequently logs in. So against a stolen PC, the passwords are safe. But if somebody sneaks into your office, hacks your PC, and then goes away and waits for the user to come back, then they can get the password.
Oh, okay. Thanks.
Just step up to the mic. I can't really see you.
2 questions. Is the credential vault, does it roam to other devices that are maybe trusted on your account?
Yes, sir, it does. Thank you. That's another feature of Cred Vault. It roams.
Second question is regarding the self-signed certificates. So other than being able to reuse your own officially signed certificate, is there any advantage to using one that is official? Is there maybe even a disadvantage because there's a chain to validate on each request?
An advantage of a properly signed certificate would be that it also works for web browsers. So if you want to support web browsers in your experience properly, you're going to need a commercial certificate anyway. If you only want to talk to your app, then I don't think they have a lot of advantage. You completely own revocation, so if there's an attack against your server and your private key is disclosed, you better get on it. And like I said, the revocation procedure is push a new certificate onto your server and push an update to your app through the Windows Store. All right, well, if there are no more questions, thank you very much, and you might even have time for some lunch. Oh, wait, there's a question.
I'm not sure if you'll have the answer to this question, but I was curious if there's any best practices in terms of saving files for an offline mode when you encrypt it on the disk. Is there any way to have another application, like say Microsoft Word, read that encrypted data? Or do you have to basically just have it unencrypted?
I'm not sure I understood that.
So basically, if you cache a file offline and encrypt it, is there any way you can have a third-party application read that file, like basically decrypt it? Is there any best practices
If you
around that?
encrypt with DPAPI, then anything the user owns can decrypt it.
I see.
The credential isolation in Credential Vault, that's a feature of Credential Vault, that if an app makes an ask to Credential Vault, then Cred Vault will say, oh, are you the same app? Then no. But if the user has access to all of the apps, all of the Credential Vault stuff, all of everything, because the user has the DPAPI key. So if you encrypt data with DPAPI, then yeah, Word or any other app can read it if it calls DPAPI to decrypt.
Cool. Thanks.
And thank you very much.